let's look here at factoring a multivariate polynomial by grouping. And we'll start with problem type 1. So here we've got the common instruction factor, but this looks really kind of weird. It's like, wait, there's no squared things in there. Something's not right. But actually there is. This is just a new type of problem. So make note here that we've got a common factor in some terms. Like for instance, we have a common w in those two terms, right? And if we look here, the 10x and the xu, we've got a common factor of x in there. So what we're going to do is we're going to just factor those out. So if we look at this original problem right here, we can group it. We can just say, oh, let's just group these two together because they have a common w. That's all they've done here in this step. And let's group these two together and notice that they've got a common x. So now we're going to factor out that common w. So here we pull this w out front, and that's where it comes from right here. And in this case, we pull the x out front, and that's where it comes from. So it's kind of like undistributing factoring. That's how it works. Then we notice, this is the really cool thing. Now we notice that inside the parentheses, we actually have the same thing. Even though they're written in different order, we can rearrange them. So they're in different order. We rearrange them, so now they look the same. So now what we have are two terms with a common factor of 10 plus w. Let me open this up and show you. So we've got w times u plus 10, and then plus an x times u plus 10. And if we notice here, we've got a u plus 10, and here we've got a u plus 10. And we've got two terms, right? Because here's the plus sign, so we've got a term here and a term here. So it's just like we did in this step where we had where we have uw plus 10w. We've got a common factor of w with two terms. It's the same pattern. And we pull that w out, and we say it's w times u plus 10. Well, in this case, we're going to pull the u plus 10 out. So we're going to say u, whoops, let me do that in black. U plus 10 times what? Well, it's times a w in the first term and then x in the second term. So we have a w plus x. And what do you know? We factored it, because remember, when we factor something, it looks like this. So the pattern is to take a look and look for like terms. Now you notice there's lots of like terms here. We also have, for instance, u's in the first and last, and 10s in this middle. If you had decided to group them by those, it would have worked out just the same. And either way was just fine, because we end up with the same answer. All right, lots of complex stuff going on, but let's look at another example to practice. Okay, so here we're going to look, and we're looking for common factors in pairs of terms. Okay, so let's say here's a 3w. Now let's look for any other 3's or w's, and it may not matter, but it might, because for instance we've got a w there and a 3 there. So let's say we pick this 3w and this wu. We have to make sure that these two terms have common factors, in which case they do. They have y's. So we're good. We can choose that. We can do it that way. So let's rearrange it so that those terms with the common factors are next to each other. So we're going to say 3w plus wu, and then minus uy minus 3y. And I'm going to go ahead and do my bump, put in my secret invisible 1, bump. And now what we're going to do is factor out. Common factor in the first two terms is w. So I'm going to write w times 3 plus u. And then what's the common factor in these two terms? It's y. And in this case, I'm actually going to use a negative y, negative 1y. And that's going to give a positive u. Whoops. A positive u, and then plus 3. Because a negative 1y times u is a negative uy. Negative 1y times 3 is negative 3y. And now we notice that these two terms, or these two parentheses, are the same, even though they're written in a different order. So we could rearrange them and say, oh, I'm just going to choose to write it as 3 plus u. You could use u plus 3, it doesn't matter. And then what's that multiplied by? Well, it's multiplied by a w minus y. And you could write it as a 1y. Either way. So wow, we factored it. Whoops, there's our final answer for this one. So it kind of takes a lot of thought, but it's really only 2 or 3 steps. Not too bad. Here's another practice, another example you can see. We've got 6's in the first two. That's kind of nice. Maybe we can just try that. Let's check. Do we have something in common with the next two? Yeah, we got a v. Alright, so let's do it. Let's factor out a 6. If we do, we get a w plus x. And then we're going to factor out a plus v. And what do we get? Oh, nice. W plus x. Okay, that's cool. These two are the same. So that means we can just write a w plus x. And then what do we get in the next parentheses? A 6 plus v. Blam, we're all done.